Hey, what's going on YouTube? We're back with another day practicing mathematics live on the internet. I'm joined by my beautiful cat, Luna. She just jumped up right in time to once I was ready to start streaming, and now she's gone. Thanks for watching. So it's another day, day 2 in this cycle, in this rotation through freaking representation theory. So this is our third cycle in representation theory, our third time around, which means that we're going to be doing 3 streams in a row. This cat is so distracted. She keeps scratching the lamp all the time. She's very annoying, but she's so cute though. So welcome if it's your first time to my stream. It's nice to have you. Introduce yourself in the comments. Say hi if anybody's still watching. I see that a few people watch the VODs, but I'm not sure. I'm really just not sure if I want to keep VODs up at all, dude. I don't know if it's really worth it. Anyways, this is the introduction. This is just kind of the small talk portion of the stream. Just kind of talk about random things, introduce myself for anybody who might be new. I am a former mathematics major. I graduated in 2012 with a degree in pure mathematics. I was trained and ready to go to grad school and become a research mathematician. But I decided I just didn't feel like I was cut out for it. I didn't feel like I was in that top 1%. It just seemed like it would be a hard life, dude. Like, mathematics is an art form. Mathematics is really an art form. And just like in any field of art, that's a hard path. That's a hard life. So I don't know. I felt like I'd be like a fairly average to below average researcher from what I could tell. And at the same time, the iPhone was coming out and really changing the world. And I was paying attention from the very beginning. I decided to go into software. I was always pretty good at coding, and it turns out that was a good decision. I ended up working for 10 years in Silicon Valley, starting out working on iMessage at Apple. Then I worked on payments at Lyft, and then I worked on YouTube at Google. After those, then my entire team got laid off from Google shortly after ChatGPT. So I like to say that AI took my job, and I think that there's a strong argument actually to be made there. Nowadays, I live somewhere where I would have to work remotely, and dude, remote work just isn't as much fun. It's just not as much fun to me as, actually working with people in person and getting lunch with really smart people. I miss that. So now I find myself just being drawn back to mathematics. I love mathematics. And for the last 2 years, I've been tutoring and just getting really good at teaching the K-12 curriculum. So right now I'm on a path to get state licensure and become a high school math teacher. That's my new dream. But I want to be a high school math teacher who's studying graduate level math for myself for fun as a hobby, because I think that helps drive the message that that I say to my students. There are people out there who study this stuff for fun, believe it or not. There is a whole field of math called recreational math, but then other people just like studying. And it's just like, doing Sudokus or crossword puzzles or something. It's kind of pointless, but it's really pretty and really, it stretches your brain. So yeah, that's kind of part of my thesis, my message here. You can study math as a hobby, as an adult. Math for fun, for adults is kind of my idea here. So welcome to my stream. What's up, Zafarb? How's it going? Okay, so good to see you, bro. We got another day on group representations. I literally can't find my paper book right now, so I guess that is the universe telling me, let's just work with the PDF today. So, last time we got pretty far into trying to study chapter 3. I think we did 3.1. We got... Okay, let's try to recall. I definitely did not complete all of section 3.1. We got through the definition of a representation. I remember we got to the definition of equivalence. We worked this example. What else? Ooh, you used to think that you liked studying, but now starting research, you're like, this is even more fun. I think I might have just had a bad experience with research. I'm curious because you're doing research over the summer. I feel like for me, and with hindsight, with just me knowing and having worked in industry for a while, I think that there's something about mixing studying with research. Like maybe if you're just focused on research and just working, I could see that being really fun. Like I could see that being ultra fun and just going all in. But there was something to me about doing like dabbling with research, just doing like a little bit of research at the same time as taking a heavy course load with, hard classes like, master's level abstract algebra and master's level analysis while doing undergraduate research. I feel like I didn't get a very good sense of what research would be like. I don't know. Or like I felt like I got enough of a sense of what it would be like, and I was like, I don't know if I would be good at this, but I didn't get to really just dive all in and make it the focus for a period of time, if that makes sense. I don't know. I was just also a fairly immature student. I needed more maturing in general. Like nowadays, I think I would love math research, and I kind of want to do math research for fun in a way. I want to work on formalization of math. Like, dude, that would be my research interest. But it would be like quote unquote research just for fun, like what you said. I'm interested in formalization. I'm interested in lean. I'm interested in applications of lean to general functional programming also. I'm interested in formalization of general purpose software. Like, let's see, how many letters are in formalization? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is a common thing in software. I'm going to call this F11N. Formalization of general purpose software. If that makes sense. If it's lean formalization, I've heard there are large-scale projects out formalizing a theorem together. I'll need to search it up for more details. Yes, that's what I want to get involved with, kind of for fun, in some sense. Like, formalization, this kind of like crowdsourcing, like not just general software, but also formalization of like crowdsourced theorems. So like I know that Terence Tao, for example, current ongoing is FLT. Yeah, in particular, I would love to work on. That's exactly what I would love to work on. Like I would like to contribute to formalization of FLT, like most specifically. That's actually why my profile picture is Fermat's last theorem. What colors did I use? I used green, A to the end. This green looks pretty bad in this iPad Bo. Well, a to the n plus b to the n does not equal c to the n anytime that n is greater than 2, right? This is my profile picture, and it's because I would actually really like to frickin' contribute to that. That's a lot of scary number theory. I know, but I need to learn some. I need to learn some of that scary number theory, and I know that you would need so much. You need a lot of linear algebra. You need a lot of representation theory. You need a lot of blah blah blah, lots and lots and lots of stuff, right? Yeah, dude, I think that'd be super sick. Like if I could help contribute to FLT just for funsies, just for like the open source, crowdsourced, contribution. Dude, that sounds absolutely sick. My internet won't let me stay live on stream. I'm sorry to hear that, Lockheed. Dude, I really enjoyed our convo yesterday about the hints toward category theory. That was a really fun, really, really nice convo. I haven't had time to actually sit down carefully and, quietly think about working your exercise, but thank you, dude. Again, I will totally work on that at some point. Yeah, a lot of scary number theory. Yes. Okay, anyways. For now, just one topic at a time. One topic at a time for some focus. Just working representation theory only. So what did we do last time? I do remember we worked this example, which was really quite nice. And then I think we did work this example of Sn. A G invariant subspace. I believe we defined a G invariant subspace. We defined the direct sum of representations. We got... I think we saw that this is a direct sum of two representations. I vaguely remember this. Then I think we skipped this example, so I'm going to add a little to-do bullet here. I believe we didn't get to that one. I believe we didn't get to really clearly seeing the trivial representation. I think we defined, I wrote this down, the definition of an irreducible representation, and then any degree 1 representation is irreducible since C has no proper non-zero subspaces. This is a point where I vaguely remember looking at this stuff, but not really completing it. Yeah, we skipped those parts. I think I wrote down this proposition. So I made some partial progress writing down these definitions. But we definitely did not get... Oh, wait. Equivalent to decomposable... I don't think we're there yet. And we definitely did not get to Maschke's theorem yet. Those are all to-dos. We haven't even started Maschke's theorem. A unitary representation. Yeah, we haven't started section 3.2. But I think we only need 3.1. I wrote down exercise 3.1. And we've made some partial progress on 3.1 because, so this is our goal for today or tomorrow. I think today is going to be theory and note-taking. I mean, in this, it says you may assume that it's a representation, but I wanted to prove it and verify that for myself. Yo, you're compiling LLVM. Why? Why, bro? Why? That's cool. And hell yeah, Zafar, lock in, dude. Lock in with me. Okay, so I still want to assume, I still want to prove it. I don't want to assume that it's a representation, but proving that it's irreducible, I think we got to all the definitions. So we're not even going to think about starting Maschke's theorem today, so I'm not going to put a bullet point there. But today and tomorrow, I want to get through all of 3.1. Oh, you use Arch, by the way. I use Arch, by the way. I use Vim, by the way. Dude. I use NVim. NeoVim, by the way. Anybody watch the Primogen? Do you know the Primogen? Dude, I want to get Prime in the stream someday. This is like a catchphrase from him, like, I use Arch, by the way. And I use NeoVim, by the way. These are like little catchphrases. Oh, you do watch him? Hell yeah, dude. Primogen on math stream. It could happen. Dude, it could happen. He likes math, too. He was, like, bad at math, and he has a whole inspirational story about how he, decided to get good. Decided to, like, freaking, lock in and learn calculus. He always tells that story, right, about locking in and deciding to, like, he doesn't use the words, but, like, deciding to adopt the craftsmanship mentality. And I'm a big fan. I don't really watch too many streamers on periodically now, and I'm not really like trying to stay tapped into programming as much as I used to. But I used to watch Prime. Yeah, he's awesome. Ooh, 1170 out of 4300 files. Anyways, you're distracting me. Let's go. So definition. Completely reducible. Something is completely reducible if blah blah blah. If the vector space is a direct sum of n vector spaces where all are non-zero G-invariant subspaces, and phi bar vi is irreducible. I don't remember what this notation means, but okay, phi restricted to V, or phi acting on VI or something. But so if the representation is irreducible on all of the decomposed vector spaces, right? So then that is what a representation being completely reducible means. Phi restricted to VI. Yeah, that's what I was thinking. Okay, after you read the definition of irreducible representations, then you're ready to understand half of the monstrous moonshine conjecture. Are you serious? Wait. Bro, you're telling me that right now I can actually understand half of this badass theorem? I know what you're talking about, too. Monstrous moonshine. Like, what a romantic name, right? The monstrous moonshine conjecture is a connection between like a huge group, and by huge I mean like really, really huge, with like coefficients of some, isn't it something like this? Coefficients of some elliptic curve? it's coefficients of something. And let me underline that it's I think the biggest group, right? Like the monster group. We're talking about the monster group. And this connection sounds like moonshine. Like somebody's just drank too much moonshine. That's fucking bullshit. That's impossible that there's a connection between these two things. I know, what else do I know about it? It was proved by Richard Borchards. Big Rick, or whatever. What does Leo call him? Big Rick or something? Big Rich? And I think that he won his Fields Medal for it. I'm trying to think out loud before I read the chat. I bet you all are answering my questions. Or, yeah, what else do I know? So this is found by Richard Borchards, Fields Medal, somewhere around 1980, I think, question mark. But for anybody who's watching and is not aware of this stuff, this is recent. This is recent math. Also, by the way, Rick, I don't know if he goes by Rick, but I'm going to call him Rick. He doesn't stream, but he posts entire lectures. And he's a huge inspiration for what I do, for my style of streaming, of like you watching me working live. I'm on the side. You can see my iPad as I'm working. Huge inspiration from his YouTube channel. And then what else? The connection was coined moonshine The conjecture was coined moonshine by John Conway. The Game of Life guy. Yeah. So he yeah, that's all I know. Okay, so let me read. Let me catch up to you. I think it's the right-hand side of that equation you can understand. Ooh, cool. It's related to the dimensions of the irreducible representations of the monster group with the coefficients of the J invariant. Okay, so it's not... Here, let's say the chat is purple, because I'm going to start streaming on Twitch soon, by the way. Coefficients of... What is it? Of the J invariant. So I was somewhat close, and at least I was confident that I didn't know this. You know, I put this in parentheses. I was like, of something. I think I'm speaking out of my ass saying that it's an elliptic curve. It's something called a J invariant. And even Lockheed doesn't know what the hell that is. But you're saying that the left-hand side, right? That the irreducible representations of the monster group. Hell yeah. Okay, cool. So you're saying the irreducible reps of the monster group. That here's the connection. Here's why we're talking about this here. Like we have enough. Oh, this is super sick. Okay. Dude, that's so cool. Okay, so now I have a little connection. Because I was saying that it's some connection between the monster group and this other thing. I was about to say the size of the monster group, but I was like, that doesn't make sense. Like, the monster group is one gigantic, the size of the monster group is one giant finite number. So it couldn't possibly correspond to coefficients, multiple coefficients. I was like, so I know that I'm missing something here. So what those coefficients are the irreducible representations. Oh, dude, that's super sick. I'm guessing the size of the irreducible representations. Oh, dude, now I know a little bit more. I understand a little bit more about this thing. Dude, that's awesome. Thank you, bro. It's related to the dimensions of the irreducible representations of the monster group with the coefficients of the J invariant. I have no idea what the J invariant does, though. 1 plus that comes from the dimensions of irreps of the monster group. So I should call this irreps, you're saying. Okay, hell yeah. That's standard, right? Irreducible representations are the irreps of G. Right? I watch that guy's algebraic geometry lectures on YouTube sometimes. Me too. I've fallen asleep to Big Rick. I fall asleep sometimes to his math lectures. I've watched or listened to some of his lectures on elliptic curves. Yeah. Well, I guess technically coefficients of the Q expansion of J invariant. Still no idea what that is. Okay. Q expansions of the J invariant. Hey, dude, this is where I'm telling you, this is what I mean by muscle memory, or just like flashcard memorization of math. Like, the fact that you know those words, like, you can learn some math, like a little bit of math by osmosis. Like, I can say some words. The Q expansions of the J invariant. I don't know. I think that's how somebody can learn. Like, just a little bit by osmosis, a little bit at a time. It's kind of like learning a piece in classical guitar by muscle memory without understanding the music theory of the passages, without the deeper understanding. You can just press buttons and just like power through just muscle memory, learn something. Like, kind of equivalent in math is that you can just learn facts without fully understanding them. And then over time, you come to learn and understand deeper and deeper, like someday you may have just memorized that the monstrous moonshine conjecture connects the irreducible representations of the monster group with the Q expansions of the J invariant. Like, that's like a fact that you can memorize and put on a flashcard, on like an Anki flashcard or something. And you don't have to understand everything. You don't have to know what those words mean, but you can still memorize that fact. And then someday when you're studying representation theory and you get to this definition and you're just like, oh, holy crap, that's what irreducible representations means. Like, I kind of believe this somewhat strongly. And that's a little different way to study than people normally do in undergrad, or I don't know. You know what I mean? Oh, I don't know if it's standard, but blame K if it's not standard. Okay, heck yeah. Coined by K. K, fellow streamer, shout out to K Theory, coined the term, the Q expansions. I feel like I've heard that term from his streams. I've been in his streams plenty of times, and I've heard him say K expansions or Q expansions. I don't know what that means, but I love it. Like, I've heard that term before, and someday I'll understand what that means, along with you. Dude, this is super cool. Thank you. All right. And yes, I knew that it's the largest. The monster group, there's the monster group and the baby monster, and in some sense, they are the largest finite groups. Irreps. Oh, I see. Irreps. Got it. Q expansions is standard. Okay, I gotcha. I like irreps. I think that's great. I'm gonna credit K-Theory for this one. Shout outs to K-Theory. I hope that we can do a follow-up representation theory stream soon. Anyways. So, today, believe it or not, I want to start over from the beginning, and I want to review all of this stuff because, dude, it was so long ago at this point. When was it? This was the intro. Chapter 3. Dude, this was May 11th, bro. That's a while ago. Today is now June 9th? 10th? It was a month ago, dude. So, I need to really, I don't know, I need to review. I'm gonna have to, I think, start over from scratch. And I think that's okay. We're not gonna get to Maschke's theorem, but there is a second section. How do I want to do this? I don't know if that's necessary. Anyways. Here. Today we're only going to be focusing on 3.1, I think. Okay. So what's up, everybody? Here's some goals from last time. I wanted to be able to write down the statement. I can just state it and just write it down and sort of understand kind of what the heck our goal is. I wrote down the statement. Then we did some reading and proofs. An example on SN, definition, example, a remark. This time we're going to be, or I said that next time we'd push forward 3.1.14 and table 3.1. I read those, but we didn't have time to actually work them. And then the definition of irreducible rep. We did do there's this statement in proposition 3119, and I think that would be the tool that we use to solve the exercise. And then we revisited the exercise, and revisiting it after actually learning the definitions and getting to a proposition that I think can be used as the tool to solve this exercise. So that's a little refresher. So it's been so long that we're going to do all this again. But this time we're going to do it quicker. Hopefully. Last time it was a 4-hour stream. This time I need the muscle memory repetition rep. I need a rep on this. And I want to, believe it or not, I actually want to just freaking do it all over again, even rewriting that. All these things This time I want to see if we can get through all of it. Last time we weren't able to get to the table. We weren't able to do a lot of these things. But now I have like a firmer understanding of, where all this is going. I'm going to put a bullet point. For those who know the term, I really love and believe in bullet journaling. Any bullet journalers in the chat, by the way? Anybody out there a bullet journaler? I love bullet journaling. I really, really do. Also, let me know if the iPad is ever lagging. Yeah. Okay. So, let's add little bullets for every to-do item that I want to work through. Let's remove these little highlights. And this part is fairly simple. I may be bullet journaling subconsciously. Hell yeah. Dude, if you're interested, I will take a 5-minute detour to talk about bullet journaling. Because it's such a damn cool system. I mean, I could link you to resources talking about it, but if people are interested, I'd be happy to talk about it. I'm a big fan, dude. Turns out I have ADHD. That's something I've realized late in life. I only realized this after living with my wife, and she's like, you might want to look into this. And it's like, oh yeah, actually that tracks. A lot of these things, I got really interested in productivity systems, and I spent a lot of time trying to learn about productivity hacks and productivity things to really hone your focus. And I got good at being productive, and working with ADHD as opposed to, not having it controlled. So I feel like I have pretty good control of ADHD. Nowadays, I take meds some days, but not all the time. I feel like I have ADHD pretty well under control. And things like Pomodoro method and bullet journaling are both super good productivity hacks from productivity people. So I'm a big fan, is all I'm saying. Anyways, I don't know if that's... Oh, I hate it when MathLib doesn't have a definition that I need. Wait, are you formalizing? Are you formalizing your stuff in MathLib? Oh, I didn't know that you're formalizing shit. Dude, let's start formalizing. Okay, I know, ADHD, inattentive, distractible ADHD, right? Dude, I think it's a necessary characteristic if you're a streamer. So some people are like, why the hell do you keep revisiting linear algebra all the time, right? It's because you all have seen this, but... Well, let's do white. So, linear algebra is going to begin with Fraleigh. Eventually, we're going to go to Axler at some point. And then at some point, I want to go to Axler plus Lean. I want to... As I keep revisiting the basics and keep coming back to it and doing the basics in more depth, just the basic definition of vector spaces, and it's starting to feel too easy and like a waste of time. Let's go in more depth. I mean, maybe even before we go to lean, maybe before that, like at some point I want LaTeX on the stream. So yeah, Zafarb, yes, Zafarb. This is where I think that you would like the bullet journaling system. It is so damn good and flexible for that reason. Like, it's not like a heavy duty freaking prescriptive thing. It's a pen and paper productivity to-do list organizer thing. Since you said that, and I feel like you took the bite. The way I do it, and I think a lot of people do it, is it's a paper notebook. Today is the 10th. It's a paper notebook, and on one page you have your to-do list. When you complete a to-do item, I cross it out with an X. In bullet journaling, if you don't complete an item, you push it forward. And if you want to push something to a backlog, then you do like a back arrow. Like, this is something I'll do someday, but it's not important in the short term. I also use like a single line, which is like, a partial X is a single line for partial progress on a task. So then this state on the next page, you could begin tomorrow's list, and I pushed forward T2. I have partial progress on T4, so I pushed that forward, but I've also pushed an item to my backlog. And then I pushed T3 to a backlog. This might be page 1 in your book. Then this would be page 2. Now, your backlog, you could have a monthly backlog, and maybe this is page 30. Or you could also have like a long-term ice chest type backlog, and then that's page 300. But you could invent your own symbols and pick up what you want and what you don't want, what works for you, what doesn't. But it's because it's on pen and paper, it's so flexible. And you can just do the simplest damn thing. It works really, really, really well. So you sound like me, like somebody who learned obsessively about productivity systems and maybe used apps or software like Todoist or something. And then and there's a bunch of geeks out there who are freaking Obsidian and whatnot. There are some people who say that Apple Notes is over here, Obsidian is over here, and then just going back to Apple Notes, or in my opinion, paper. That this is the normal distribution, Dimwit, Rage Guy, Jedi. For me, that's paper and stuff like Obsidian. You know this meme. Anyways, let's keep going. So you said, Lockheed said, I'm making a personal formalization of locale theory following the textbook Frames and Locales. That sounds so fucking cool, dude. And you're doing this for fun, right? Like, if I understand correctly, you are, I hope you don't mind me saying, you're like an aerospace engineer, right? And that's why you're all about these, like, planes and stuff. Yeah, this is so many people I know. I know people in the real world who work at fancy tech companies, and everybody goes through this process. Like dimwit, rage guy, Jedi. Paper, digital, paper. I'm going to, make this more broad. Like for productivity stuff, like paper, digital, paper. Ooh, fuck. Dude, Zafarb, dude. Mostly because it's just a timer with no ads. You're using a productivity app. It's just a timer with no ads. Have I shown you my productivity app for musicians? I'm not gonna lie, I am trying to build audience for reviving this productivity app for musicians and making it a more generic productivity app for everybody. Like, dude, I would love to give you a demo if you all are curious about this. It is like bullet journaling for musicians, and it's all based around just super simple timers. But it's like a data tracking app, like a time tracker that's as simple, it's just the damn simplest thing ever. If you use timers, it tracks all your time on tasks, and it creates little bullet journals. It's like bullet journaling for musicians, and the whole time that I'm streaming my guitar practice, I'm journaling, but it's so simple because it's just timers on just a plain list of simple tasks. Like, I think that this would be an amazing general purpose timer app, and I really want to get back to working on it again. This one is for musicians because it's all centered around a metronome. So, every musician should be using a metronome. And a lot of musicians use timers. So why don't you just put your timer right there with your metronome, right? That already is a huge productivity gain, just by having the timer there. And in fact, like, if your metronome is running and then a timer ends, the metronome just stops, which is just like a really pleasant way of having an alarm. When the metronome stops, then your timer is up. But then as soon as that timer finishes, it saves it as like a data point in your journal. Anyways, I think that you would be interested in this because it's so simple. It's just a timer, but you can track lightweight data over time if you're interested in that. Bullet journaling is a big inspiration for me, and I want to build productivity apps and stuff. So, anyways, this is bullet journaling. We're getting distracted. If anybody wants to help beta test, a new app like that, let me know. Anyways, okay, goals. Let's rewrite this statement. I want to start streaming on Twitch, and I'm going to stream everything to Twitch. I don't know if I've told you all this or if I've only told my guitar audience this, but I think starting in a couple days, I want to start streaming to Twitch. And I'm going to combine all of my different channels into one Twitch account. There's going to be guitar, math, and a new channel, a new YouTube channel that is also, you know, streaming to this multi-Twitch account. jcpractices Focus. And it's like a proper Pomodoro focus stream, including meditation, reading, and, you know, silent study sessions. So, yeah, if that sounds interesting. Yeah, anyways, paper is the way to go. Look at this cat. How are you all today? Hi, Luna. So I'm going to be multi-streaming. I don't know if I emphasized that. I'll still be streaming here on YouTube. And I kind of want YouTube to be the primary community, honestly. But I don't see YouTube improving live streaming as fast as I thought that they would. I'm losing trust. I'm losing trust fast in YouTube improving their live streaming platform. And I feel like I need... If I want to try to turn this into something, I need to diversify. So, yeah. Anyways, I don't know where the hell my representation theory book went, but it can't have gone too far. So, I'm going to take a very short break while I look for this book. Be right back. Be right back, y'all. Oops, I missed the... Oh my god, so much cat hair. I missed the time to switch over. Okay, so I'm just copying this exercise. I found the book. So phi of a rotation is this matrix, and then phi of a mirror after a rotation is 0 negative I to the k, I to the k, 0. So I'm a little curious about one thing, but where R is a rotation. We know what R and S are. In this case, though, they know that S is a reflection over the x-axis. I don't know if it matters, but I usually think of S being a rotation over the y-axis. But okay. Does anybody know in the chat for the dihedral group? Is there a standard for this? That S maps to, over the x-axis or the y-axis? I know it doesn't really matter. Like, you can pick any axis. You can pick the x-axis, the y-axis, y equals x, or y equals negative x. Yeah, you could pick the diagonals. There's 4 different axes that you can rotate or reflect over. So I mean, it doesn't really matter, but I just wonder if there's a standard one. Prove that phi is irreducible. It doesn't matter which axis you take, you just got to stay consistent. Yeah, exactly. Like, I know it doesn't matter as long as it's consistent, but I just wonder if, like, when teaching, you know, in a book, like, does it, you know, is there a standard? Like, I noticed that this book uses D4, which I don't really like. I prefer D8. I've seen D8 much more. And I like Christop's option of D2 times 4. That's an interesting compromise, I feel. Like, I think that this is a really interesting compromise. That makes it explicit to everybody that we're talking about 2 times 4. Or, like, you know, D8 is not... you know what I'm saying. The size of the group as opposed to the number of vertices. Okay. So, that's a similar thing where it doesn't matter, you just need to stay consistent, and it's a style thing, but I just wonder if there's a standard. All right, prove that phi is irreducible. So, one more time. This time, trying to do it from memory. Hey, what's up, pumpkins? How's it going? How close was I? This time it was from memory. I know it wasn't very long ago, but it was a little spaced repetition. How close was I? Yep, okay, I to the k. So I to the k is in the top left, negative I to the k is in the bottom right. And then when we do a reflection, then we reflect. It's kind of, yeah, I see that it's like we reflect over the x-axis of the matrix, which is pretty, I don't know if I can call that a coincidence or not, but wow, Math Channel's really growing well. Yeah, it's growing beautifully, dude. Definitely better than the Guitar Channel. Like, I sense that there is, you know, real potential in the Math Channel. Guitar Channel does too. I'm not gonna like give it up in any way, but Math is growing beautifully, and I haven't even started posting shorts or anything. So, yeah. All right, so I got it from memory this time. Let's see, what kind of progress can we make on this before we look into the book? Also, dude, Lockheed, I'm going all in on adopting functional notation, functional programming notation. I don't know if that's, heretical or something. I feel like it's just ever so slightly, heretical. How do you feel about it, math nerds? Like, if there's only one argument to a function, I think that we should omit parentheses. I like it. That's what we do in functional programming. I think it's a good idea. If you all are not offended, I will continue doing that. Okay, that may be a tad cursed. I know, when I tried it on this one, I was like, ooh, this one is making me slightly uneasy, but I think I like it, actually. Is this cursed? What do you all think? Like, I don't know. This made me uneasy when I wrote it. But if I'm going to adopt that idea, it needs to work everywhere. Why doesn't it work here? I kind of like it. GL2C. Is that a problem? Does it make you mad, bro? Could this be my rage bait? My rage bait is thumbnails with really cursed math notation. I'm a hobbyist. I can do whatever I want. I'm going to rename D4 to D8 here because I like D8. But I think that this deserves parentheses because Luna, you are a cat. You are a cat, Luna. Hey. Oh. I don't know. Opinions, feedback is a gift, everybody. It felt a little cursed when I wrote it, but it's growing on me. It's actually growing on me. What do you all think? Okay. So solution. We want to show that we want to show what is the definition of an irreducible representation? We want to show that there are no non-trivial subrepresentations, I think. We want kind of like this, like, I don't even remember the right notation, but we want some kind of containment thing, like, that there is no what would be a way to write this? I.e., if psi, maybe I'll use another letter. If psi is a proper subrepresentation of phi, then psi is the trivial representation. Is that correct? Okay, let me check the book. I think that it's something like this. We want to show that phi is irreducible. So the only proper... I remember my brain cells dying from this exercise. Oh, really? Why did your brain cells die? Like it was hard or it was trivially easy for you? Okay, so how close was I? Oh, yeah. So, it's not... trivial is not... the trivial representation is not denoted as 1, but it's... the trivial representation is 0. And it's not subspaces... Oh, okay, wait. Is this equivalent? Maybe I just wrote it a little slightly differently. A trivial representation. Okay. Trivial representation is a homomorphism from G to C star. That's not the same. So I was almost... I had something kind of close, but it's not actually correct. Okay. So this is what I wrote, and it wasn't completely correct. A non-zero representation of a group G is said to be irreducible if the only G invariant subspaces of V are trivial and V itself. So I was kind of close. It's just how I noted it. Let's write out that definition more carefully. Definition. I looked at it for a second. Let me try. Oh shit. Okay. A representation phi from a group to a vector space is said to be irreducible if the only G invariant subspaces of V are the trivial subspace and V. Is there anything wrong with saying 0 in V? Is there anything wrong with saying 0 in V? As opposed to bracket 0, braces 0. We'll take a dinner break now. Hey, enjoy your dinner. What's for dinner, dude? What's for dinner? How close was I? That's close. A non-zero... Oh, I needed the word non-zero. A non-zero representation... Oh, and this is G to... Not G to V, but G to GL of V. So I got that part wrong. I was close. Of a group G, that's implied. I already know it's a group. Is said to be irreducible if the only G invariant subspaces of V are the trivial subspace and V. So I got the other parts correct. So, okay, we were close. We're getting closer. A non-zero representation phi is irreducible if the only G invariant subspaces of V are the trivial subspace and V itself. Getting closer. Okay, so in essence, we want to show that Luna, she may have just broken my book. Did she just break this book? She just knocked this book down and it landed in a pretty bad way. It's still hanging on by a thread, like literally like a little thread. Yeah, anyways, Math Channel, I think is growing. I think we are making progress here. If anybody has any feedback, requests, things that you'd like to see from the channel, I'm all ears. I.e., we want to show that if W is a subspace of V such that W is not equal to 0 and GW, so W is G invariant. What does that mean again exactly? What does G invariant mean? I believe that a vector space W acted on by G means that phi G W is in capital W for all group elements G and vectors W. I think that it's something like this. I see some traces of Luna there. Yeah, dude, it's impossible. I give up. It's, you know how like Alex Hormozy and like other people out there, but like, big influencer-y kind of people, but like I know Alex, I don't know. He's got his issues, but like he's got this like nose thing on his nose and he needs it for himself, but he just leans into it as like part of his brand. It's like a signature. Like, oh, he's the guy with the nose thing. I could be the guy with the cat hair on a black t-shirt. Like, I just lean into it. I could wear a different color, but black helps highlight Luna. And everybody loves Luna, right? What's up, Alan? Bro, I was thinking, Alan, it's probably better to ask you in a math stream. Weren't you the person who was there when I went on a little sore hands rant that I felt like he was grabbing something of mine? How are you guys are so smart at man in maths? I don't get that thing. Dude, it's just practice. It's practice like anything else, dude. How do you get to Carnegie Hall? Practice, right? But yeah, you I think were there, and you commented on his video. If I remember, I haven't looked it up who it was, but somebody commented on his video and asked, "Did you get this from jcpractices?" Yeah, man, I think anybody can become smart. I don't believe, I mean, there is some level of raw genetic intelligence, maybe, totally, but like, dude, I think 90%, 99% of it is work, is hard work. Because even the people who are naturally gifted or who, were ahead without working in high school, some of those people crashed hard in college. Like, I'm thinking of one person in particular, like one of my best friends. Like, I don't know. Some people, I hope he's not watching right now. He might be. Some people crash hard when you're just like naturally fucking gifted and you don't have to work very hard. But then everybody hits a wall at some point, dude. And at some point, you have to learn how to just work hard. And at some point, learning how to work hard counts much more than being smart. So you may not feel like you're smart, but you could learn how to work hard and you can get through that barrier and you can do whatever you want. Like, I think anybody can learn math, but it involves learning how to work hard. And in fact, dude, okay, you're gonna get me on a tangent because I love this topic. At the code guy, by the way, I'm a code guy too. We got some code people in this chat. I used to be at Google and a bunch of other stuff. I used to work Apple, Lyft, and then Google, and now I'm returning back to math. But yeah, I'm a software person. How did you get so smart? Is what the code guy says. Dude, just freaking hard work. It matters so much more than anything else. I was gonna say something more interesting than this. I don't know. I blanked. I lost my train of thought. Oh well. Nice to meet you, man. Nice to meet you. How did you get so smart? Hard work, dude. That's what matters. Persistence, grit. Oh, and dude, like, math is the best way to train grit and hard work. Math is the best for this. Because it's infinitely hard. No matter who you are, something that's beautiful about infinity is that no matter who you are, math is going to get hard. Nobody is just naturally good at math forever. Whoever you are, like math professors that I know, get stumped for weeks at a time, years at a time on a single problem. And they get just as stumped and as stuck on problems as high schoolers in math who get stumped on a problem. The difference is that they grow to enjoy that. They grow to enjoy, and maybe you could call that grit or something, but there's some people who enjoy that process of being completely stumped to understanding. Or maybe I'll say stumped to Eureka. Mathematicians just like actually literally just get off on this. I see someone who loves pain. No, somebody who loves the just brilliant, just moment of like, oh my gosh, I solved that problem. Give some tips, sir. I'm entry-level engineer. You got your first layoff in the month of April. I'm sorry, dude. Yes. I've got tips for software engineers for sure. Here's my path. Bachelor's in math. Apple. iOS Eng. Well, no, let's do it this way. Let's do it slightly different. Bachelor's in math, you graduate and you don't know anything. You're not valuable. I self-taught iOS engineering. I taught myself, mostly, how to code. I built some apps and things on my own. Impressed some people, got into Apple, and did iMessage. Worked on iMessage there. Then I went to Lyft. I worked on payments. Then I went to Google, where I worked on YouTube. Both infra and product stuff. Then I got hit by ChatGPT layoffs. Shortly after ChatGPT, there was a mass layoffs of 12,000 Googlers. And now I'm in the process, not a meth teacher, a math teacher. Yes, I am training to become a high school math teacher. And YouTube. I consider this kind of like teaching also. So, there's my path. OMG, I'm glad I landed here. Oh, wow. Yep, that's the path. Dude, the thing is that I love problem solving, bro. A bachelor's in math will teach you how to love problem solving. So that works really well to, that works. That's a great skill at big companies or at big companies, they used to pay for awesome problem solving skills, and they still do. But math will teach you just pure, raw grit and problem solving skills. AI is taking away all of that problem solving fun, dude. This is my opinion. This is just my opinion. Let's just go back to hearts. There's lots of problem solving, but there's also teaching and humanity and everything in teaching. So I'm growing to love teaching just as much as I liked problem solving. Yeah. Thanks. Cool. I ran for maths all the time. Can you give small tip for newbie to math? I think that's it for right now. Tips for newbies to math. I mean, what is your goal? That's, what is your goal with math? Like, why do you want to learn math? Is it for fun? Is it for like personal fulfillment? One thing I like to do, because I'm studying math as a hobby, since you're a code guy, you know what I mean by breadth first search and depth first search versus depth first. This is called spiral learning. And so I was doing some linear algebra, I was doing more linear algebra, then I was doing more... Yeah. So we got some amount of linear algebra every loop, but then at some point, I'm starting to add a little bit of calculus and a little bit of representation theory. And then I come back and I do some spaced repetition. I do more calculus and more representation theory. And then we do a bunch of linear algebra again. But now we're doing more calculus and more representation theory. So this is where we currently are. We're in cycle 3, day 3 of graduate level math. Hey, what's up, Paulo? How's it going? So what I'm trying to say is go for both depth and breadth. And that's my tip to you. Spaced repetition. Look up this word and you'll find out what it means. Spaced repetition with breadth first search. Yeah, and no worries. I love geeking out about math, about programming, and you said that you need maths to become the best programmer in the world. I don't think so. I don't think you need maths to become the best programmer in the world. If that's your goal, I would be build a project, bro. Okay. Because I'm a mentor. Like I if you want like a one-on-one tutor in coding and you want to help me build iOS and Android apps, I've got so many apps that I would like to build. It could be like an internship or something. So you said, I want to be the very best. Right? Dude. Then what you want is to prove that you can ship. Like build stuff and actually get users to use something that you built. If you want to be the very best and you want to impress people, you don't need math. Math isn't going to help that much. Most of the problems are based on maths in LeetCode. Okay, yeah, if you want to practice LeetCode, you don't really need math. I mean, you need to practice LeetCode, and you do need to practice your data structures and algorithms. Yes, do your spaced repetition, do your practice, but yeah, you don't need math for that. You need to, you want to ship and practice LeetCode, etc. Yeah, you need to practice some kind of fundamentals and treat LeetCode like part of that, but also look at katas. It's very similar. Treat LeetCode like katas, which are solved exercises that you've done before, but you're practicing and perfecting the motions. So I've never really talked about this in the math stream, but I take inspiration from katas in programming, which comes from katas in karate. Probably the best way to improve is to do squats and sit-ups and stretch very well. That actually might be a very good way. If you start there by learning how to frickin' lift and build yourself, that's another place to learn grit. I didn't learn grit through the gym, but I should. I'm not. That's another place to learn grit, but somewhere in your life, learn grit. Like this at Apple, my manager at Apple, he said that this was the number one skill he was testing for and looking for in interviews. Does somebody have grit? Can they get through hard shit? Like, you can treat LeetCode as your place where you're training grit, but then also it's like LeetCode is kind of like theory, but then you also want practice. You also want practical, real practice. And the ability to ship is important. Include not just ship, but get users actually using your software. If you can show an interviewer that people are using something that you built, it doesn't matter what it is, that is a huge positive signal. That is great signal. But if you just show up and you say that you can LeetCode really well, that doesn't go very far. That is table stakes now. Languages, I don't know, dude. But I love Swift, personally. Because I'm an Apple guy. And in the long run, I'd look into Swift. And you can now also build Android apps using tools like Skip. If you look into Skip, you can write code in Swift and you can build for Android, or you can go the other direction and use something called Kotlin multi-platform. I think that these are two ways. I would recommend Swift or Kotlin to you. And yeah, learn how to use Claude, but spend time every day. I don't know where the split is because I don't really code really very much anymore at all. But somewhere, this is not to scale, but some percentage of your time should be, and my guess is that it's probably less. Well, I don't know. It just depends on your goal. I don't know where the split is, but in the early stages where you are, I would put mostly without Claude. But every day, do some amount of time with LLMs and some amount of time with LLMs. Otherwise, you're going to not learn the fundamentals. You're not going to learn how to hand chisel, artisanal, hand chiseled code. This is like your fundamentals, your technique, maybe, let's even say. And your practical, or your practice. Like you're putting something into practice. Like, I'm a classical guitarist, so I think of technique versus repertoire or something. But I don't know. Technique versus practice, like you're practical. Claude is damn good though, but like you're not going to notice where Claude is wrong unless you are spending time every day without LLMs. Like, you need to be learning how to code without the LLM. I really think that that's important. I mean, you can, like, don't skip just boring old regular tutorials. Or even better yet, dude, read a fucking book, dude. Like, read a paper book. Like, work sometime offline. Don't always work online with, the cheat sheet. Like, treat it like the back of the book. Like, if you want to learn math, you can't just jump to the solution. You need to actually put in the work to stretch your brain and stretch your creative problem-solving skills. Otherwise, you're not going to learn anything. Yeah, Claude is just better. Like, if I'm coding and I really truly do want to get back into coding and building, but like, I'm a fairly senior engineer. So for me, I think that my LLM time is going to be pretty large. Like, once I finally get back, I don't know, maybe it's here or something. But it's because I've put in years of time writing hand-chiseled artisanal code and honing my, I can do it by hand. So I'm allowed to use the fancy calculator, but you need to learn how to do long division by hand before. If you're just 1 year in as a full stack dev, bro, you need more time without the LLM. I would be, if you're just 1 year in, I'd be putting, I don't know, I'd be splitting, I'd recommend probably to split like 80-20 or something. Yeah, for some people, it just depends on what you're going for. Okay, you all have gotten me on a tangent of stuff that I actually know, so I'm procrastinating the purpose of the stream, but it seems like people enjoy it, so I mean, I actually know and can speak with authority on this. But like, dude, if your goal is to get into Y Combinator, and you want to build a startup, you want to like work for yourself and you want to build your own fucking apps and everything, and you want to build a startup that changes the world, I'd be going for like a 20-80 split. But if your goal is to get hired at a company, if you want to get hired as an employee building for somebody else, like maybe you want to get into a FANG company or something, I'd be going 80-20 then. I'd flip the two. But if you just want to build and you want to build your own startup, you know, vibe coding is so valuable. Like I'd argue, if you really truly wanted to build a startup of your own, I don't know. I don't think it's wrong to say that 90% of your time should be using Claude and vibe coding, quote unquote, like agentic coding. I think that even then somebody should be dedicating some amount of time learning how to code properly, because you want to make sure that the system doesn't fall over once it gets so complex that you can't manage it anymore. But yeah, like 90% of your time should be with LLM, and then you're solving other problems. Like you need to learn marketing, distribution, like business stuff, like in like pitching to investors, like doing user research, like talking with your customers. Like there's so many other skill sets. So you should be spending some time building, but then a lot of time talking to your customers and other stuff. Entrepreneurship, right? See, Leo, this is the thing. One wonders what a pure vibe coder can do over another pure vibe coder. Yeah, that's where, if you're purely vibe coding, that's not very valuable. Anybody can purely vibe code today, but if your goal is a startup, like you're a one-man show, it's not just coding, but it's coding and other types of entrepreneurship. Like marketing. I mean, really, it's that entrepreneurship is not just coding, but it's coding and marketing and et cetera, et cetera, et cetera, et cetera. And design and ... There's so many different skills, and what you're describing sounds like a company that's only hiring a coder. Like, a company doesn't want a generalist who's good at a lot of things. A company wants somebody who's a specialist at one thing, usually. Unless you want to get hired at a small company, but even then, if they're hiring, yeah. Yeah, we'll get back to math in a second here, I promise. No, I haven't tried Steve Roman's advanced linear algebra. That sounds interesting. You have opposite opinions. What happened? Are we still streaming? What's going on? Luna pressed a button, and then she tried to start the stream. Luna. Okay. I think we're okay now. I think we're still live, aren't we? Oh yeah, but we switched scenes. Yeah, Luna just started the stream, but thankfully we're still in the same stream. Thank you, Luna. Yeah, you're very proud of yourself, aren't you? Huh? What's up? Yeah, Luna wanted to factor... Luna literally just reminded us, okay, dude, get back to the math. Luna actually just was like, all right, wrap it up, John. Wrap it up. Oh, Luna. Hi, baby. Yes. Yeah, she just wanted to be full stream. That's why. She wanted some attention. Let's get back to representation theory and the cuddles. What's up, Leroy? Dude, how are you? Okay, yeah, thanks for listening to my rant about something I actually understand. Is your goal to produce a thing or to understand something? And I don't think you get to understanding without doing problems, etc. That's what I'm saying. I think that those are two different goals, two different tasks, those are two different tasks. Absolutely. I think no matter who you are, you need to understand it over time. You should be putting in 10% of your time into proper understanding. But like, even then, understanding your business, like your entire fucking business model, and like understanding product market fit, and like just there's so much understanding that's important that's not coding. Coding can be a means to an end if you're building a company. If you're trying to like build a company and build a product for people, and the goal is the end product, then it's a good, smart thing to reduce your amount of time understanding coding. Okay, let's get back to having chat up, at least on stream. That's one nice kitty right there, that's right. But yes, Leo, exactly. Like the bots, like, I mean, it's not that different from Wolfram Alpha, right? Like when I was in school, we had Wikipedia, and we had NLab, probably, or like some other math website that was an alternative to Wikipedia. But we had Reddit, we had frickin' Wolfram Alpha, we had graphing calculators, I guess. We had a lot of tools that could do. We had Sage, I guess, and computer stuff. People were already posting. We had GitHub, and people were posting their solutions to textbook exercises, right? So when I was in school and I graduated in 2012, people were already posting full problem solution sets. And yeah, you can look that up, but if you just copy those, you're not understanding anything. You're not actually understanding, and you're not getting better at problem solving. So it's super similar. Like for math, if you're pursuing math, it's like 100% about understanding. Once you get to research, maybe it's 90% understanding, 10% results. Maybe it's 50% 50. I don't know where the split is, but it starts to become more about results rather than just purely understanding something that's already understood. But if you're building a business, if you're building like a startup, and you're building a product and the goal is the product to the user doesn't care whether or not you understand the code. Like the end user does not care how an app is built. They don't care how beautiful the code is under the hood. They do not care whether or not the code was written by a human or an AI. I think now people just assume that all programmers are using AI to build software. But it does not matter to users whether this is hand-chiseled artisanal code or not. They care about the product. Does it solve a problem that they have? And understanding is important, but I'd say that if you're building a product, it's more important to understand the domain and the problems that your users have and whether or not your solution is solving their problems. It's important to understand whether you have a business model that's going to scale and whether, whether you have a path to profitability. Like understanding product market fit and all these other aspects, understanding marketing, understanding the psychology of your users and things, like not understanding the code and vibe coding gives you more time to do all these other and put your understanding in the things that actually matter more. Like understanding is incredibly important, but if you're building a product, like understanding product market fit is more important than understanding understanding the code. Now, all of this is with a grain of salt, of course, but if you're being paid to code, if you're being hired just as a coder, then yeah, you need to understand everything and be working on your fundamentals and stuff. Yeah. What? The exact same thing happened to me. Her name is Ophelia, and she is the best fisher in all of Iceland. I don't know what, like Luna? We're talking about Luna again? It's true. In your whole lifetime, the bots could always do derivatives for us. Yeah, exactly. The bots could calculate, like we've had calculators, but we're still teaching kids how to, do arithmetic by hand. We're still teaching matrix calculating, Gaussian reductions by hand, even though computers have been better than it our whole lifetimes. And it's somewhat of a pointless skill, but we still teach it because we still need to understand it. Yeah. Life would be fun if I was born in the age of dinosaurs. I don't think that life would be fun at all at that time. I disagree. I think that life would be an eternal struggle. Like, that just sounds like a time of struggle. Dude, I find math way more fun. I'm glad that I can understand math instead of just survival. Yeah. So, yeah, Leo, like you said, without understanding of those stuff, it's hard to understand the next thing, etc., etc. Yeah. But, like, your first version of an app should, it could be a dumpster fire, and I can think of real-world apps that were just a dumpster fire, like, under the hood, until they got to product market fit. And then, once you get to a business, and the fact that your business is going to be alive at all next year, then you can start hiring experts. You can start hiring engineers or somebody else who, will care more about it not being a dumpster fire. The end user doesn't care how your code is built. Like, there's like the most elegant, beautiful code bases written in the world, crafted by hand, 100% test coverage, whatever, but they were building the wrong thing in the first place, and then that's a lot of wasted time. Yeah. Can linear algebra heal my broken soul? Yes, I think so. It's healed my soul for sure. Representation theory was so good for me, it gave me a second soul. I use that soul to take over other people's bodies, but they usually don't like that. That's interesting. I see they need the result. Yeah. GTA 5 just came out around then, so it'd be pretty exciting. You hate discrete math? Dude, I love discrete math. What? Life would be fun if I was one of Box 20 kids. Calculus is way easier than discrete math. I don't know, dude. I mean, Sudeep, are you talking about, like, learning proofs? For some people, their class teaches proofs in discrete math. I think that that's what you're talking about, isn't it? Yeah, it's a hurdle. Like, learning proof-based math is a big hurdle. Yeah. Only time I messed with HTML was on MySpace. Yeah. There's a whole new indie web happening right now of people building their own little cute web pages, super similar to MySpace right now. It's actually very cool stuff. But yeah, I'm the guy with the cat hair all over me. That's like part of my brand, I guess. All right, let's keep going. So we have this definition. G invariant subspaces of V are trivial and V. I think that this is what it means, right? So for G to act on a vector space, on a subspace, that means for all group elements, the image of that group element acting on any vector, that this is closed. I think that, I don't know if that's the right notation, but I'm pretty sure that this is a right idea. Now, let's see. Can we do this directly? This exercise. So directly, we want to show that... Well, notice that... Oh, wait, no. I mean, one thing is, we assume... This exercise allows us to show that, or to assume that this is a representation. Then, that means that phi is a homomorphism. And then that means that phi is phi s times phi r to the k, right? So, well, in particular, I can take k to be 0. If k is 0, then this is phi of 1, or phi of e, the one element, and the image of the identity is always the identity. So this is phi of s. That was kind of a roundabout way to say that if k is... I didn't need to even split and use the homomorphism property, but I can... What I'm trying to say is that this presentation of the representation, I think that I can just write phi of r and phi of s. Then phi of s is negative 1 to the power 0, or negative I to the power 0 and I to the power 0. I don't know why the textbook author writes it this way. I mean, I guess it's so that we kind of see this, it kind of looks like a inversion, or a reflection across the x-axis. But I would have just written phi of s and phi of r to the k. And then, on top of that, why do we even need phi of r to the k? Isn't phi of r to the k just k applications of phi to the r? Because phi is a homomorphism, right? So I think it's equivalent to define this representation just more simply as phi to the r, which is I, negative I, 0, 0, and phi of s as 0, 1, 1, 0. Then we can construct this slightly more complex presentation from this definition. I suppose this definition, the way that the book wrote it, the author wrote it, we can immediately look up for any group element, for all 8 group elements, we can pick one of these 2 matrices, whereas if we just presented it from this, it's like the simplest form, like a normal form or something, and then everything else we can calculate. So, but I think that we can just show that phi r w is in let's see, wait a minute. I want to show that the span of phi rw and phi sw, which maybe I write the span that way or something, is all of C2. Assuming if w is not 0. Assuming w is not the 0 vector, if I can show that the span of 2 of these something or other, Though it's not a priori an equivalent statement, you mean what I was saying, right? Meet irreducible means principal ideal is prime if and only if that element is not 1, so it's not a general equivalence. Ooh. Meet irreducible. Yum. Yeah, I need to understand what you all are talking about. But I think... Isn't this... Are you saying that this is not sufficient? Because, if W, hey, Luna. Yeah, I think that this is sufficient. Yeah. Okay, good. I think that's enough. So I'm trying to prove directly from the definitions. And I mean, when I say W, recall that this would be our vector space in this case is C2. 2 by 2 matrices. And I don't know the right notation for some subspace of C2. V is C2 if W is not the span of the 0 matrix. So now I want to use some more standard notation that if we take a matrix in W and we assume that the matrix is not the 0 matrix, then since W is not... Is this fair to say, like null or like the trivial? Luna, stop scratching the lamp. A matrix in W. Yeah, because so I'm saying that W is... You fucking cat. Okay, she's letting me know that the feeder is empty. Oh my god. She's gonna break this really nice lamp that I have over here. Luna, alright, let's take a break. She's getting her way. I don't want to reward it, but she's getting her way. So W, like our vector space, the vector space V is 2 by 2 complex matrices, right? So because the vector space is 2 by 2 complex matrices, then a subspace of V is a subspace of complex matrices, and I want to assume that it's non-trivial, right? And if I assume that it's not trivial, then the identity matrix must be in the subspace. Is that true? Wait a minute. Yeah. No, then the identity matrix must be in the subspace. Then... Oh, wait. Yeah, there's always both in a vector space, there's both a 0 element and an identity element, right? And the trivial vector space, both of them are equal to each other. So I'll be doing a proof. I'll be doing a proof involving the identity matrix and showing that the span of the image of a rotation and the image of a reflection specifically on the element that I know exists, which is the identity matrix, and I think I'll show that the span of those images is all of C2, and I think that would prove it from definitions. I think that's my plan. Oh, wait. Oh, the vector space is not 2 by 2 complex matrices. It is C squared. Oh, yeah. But they're equivalent. Like you're right. Yes. But there's an isomorphism between the two. So I'm kind of... Okay, yeah. Yes. The vector space is... Like, they're isomorphic. GL2C is isomorphic to GLC2. So the vector space is C2, but GL... Yes. Yes. You're right. So I want transformations... Okay, I need to think about this a second more. Yeah. Okay, good catch. I feel more like I'm stuck and there's no way out. I'm sorry to hear. I'm doing good, Levi. Doing good, bro. Doing good. Okay, I need to feed Luna, otherwise she's going to destroy everything. So, okay, I think I'm sort of getting somewhere, but I think you've got a good point that the vector space that I was trying to work with is... Yeah, it should be C2, not freaking... Okay, yeah. Thank you. Thank you, dude. This part is wrong, you're right. So these are not matrices. I do want complex pairs of complex numbers. Luna. Okay, be right back. Let's listen to some classical guitar. Dude, I'm happy that we sparked a little guitar versus piano flame war. Let's go, dude. Let's do this. Guitar is the best instrument, classical guitar specifically. And y'all can fight me about that. I think it is the best. I love the piano, though. I do respect the piano. I wish I knew more piano. Someday I want to learn more piano. So I say guitar greater than piano, much greater than violin. Let's have that fucking flame war over here. And I'll tell you why. Guitar is the best, classical guitar is the best solo instrument. I'm only considering those three because they're all solo instruments. You can play, there's a lot of solo violin repertoire out there. There's a lot of solo classical guitar repertoire. There's a lot of solo piano. But with guitar, you can bring it around, you can carry it, and you can play in the subway if you want to. You can carry it around and play in the park. Like, dude, you can't do that with a piano. It's super hard to go busking with a piano. You can bring a violin around, but it's just, man, I don't know. It's not the same. You don't have the polyphony. You don't have the same level of polyphony that guitar and piano have. I am jealous of pianists being able to use all 10 fingers, but your point is amazing, and I agree that being able to change timbre and dynamics, and guitar doesn't have sustain and crescendo and things like that. So I'm jealous of the violin for that, but tone, like, dude, there's so much in tone and timbre. Like on classical guitar, you can play the same note on like 6 different strings, the exact same note. It's amazing. And yeah, piano is very versatile. I think guitar and piano are similar, and they're both much better than the violin. Why are you even compiling LLVM, by the way, Lockheed? You never explained this part, and I feel like this part is important. Why, in the first place? You get a bunch of voices you can play at once with the guitar, and that's one of the benefits. That's one of the beautiful things, polyphony. Like, you've got real polyphony. I mean, on classical guitar, at least, we play with multiple voices all the time. Jazz guitar and stuff, not quite as much. I mean, well, yeah, I don't know. What's limiting about it? What's limiting about guitar? I feel like you'd more likely have guitar and piano versus others, since they are much more similar than they are to other instruments. Yep. Yeah, I just think that classical guitar is like the underrated, underdog, overlooked piano. Piano is like the jock that just gets so much attention and is the star of the show, and there's a piano in every single orchestra. But most high schools don't teach classical guitar. Classical guitar is just this overlooked, redheaded stepchild sort of thing. Yeah, they're all different. I know, obviously. We're just freaking geeking out. Bro, Lockheed, you needed to recompile LLVM because you're using Arch. That makes sense. That sounds right. Next, you need to rebuild your drivers from scratch. Your Bluetooth driver, you need to rebuild your Wi-Fi drivers or whatever. Dude, what a waste of time. Don't you have anything better to do? Get off of Arch, just start using a Mac if you can afford it. Or just use like freaking Ubuntu or something. Like, what is the benefit of Arch? Like, just use something that just works out of the box and go solve real problems for yourself, dude. Hey, Farm Sims. Yeah, there's people on YouTube who do math for fun. I think that there's a lot of fucking people out there like that, dude. Like, this is my claim. I think that there are people who study math for fun, and it's a quiet minority. But it's a large, quiet minority of people. Like, I think that there's a lot of people out there who quietly try to study math for fun. I want to try to build a community of math hobbyists like yourself. So, nice to meet you, Farm Sims. Yeah, I'm studying representation theory. I'm never going to get paid other than super chats maybe to study this stuff. I'm never going to be a research mathematician, but I just want to learn this for fun because it's beautiful, dude. Nice. You love differential equations and Stokes and Green theorems. You need to teach it to me because I never really grew to appreciate those quite as much myself. Okay, so let's see. So it's not that A is non-zero, but W or Z. So assuming Z, which is Z1, Z2, assuming that Z is not 0, 0, then either Z1 or Z2 is not 0. Without loss of generality, assume Z1 is not 0. Wait. But if... Wait a minute. GL2C okay. I mean, right now oh yeah, okay. Alright, so phi r z. So we are talking about phi r is I0, 0, negative I 0, 0, negative I times Z1, Z2 I don't know if I need to say W log, assume Z1 is non-zero, but this is phi R times our vector Z, and here is phi S, the action of a reflection on Z1, Z2. Then this is IZ1 minus IZ2. Right? And then this is I times Z1 minus Z2. Phi S is going to be Z2 plus Z1, Z1 plus Z2. So then my goal right now is to show that that the span of I Z1 minus Z2 times the span of that vector and this vector is equal to all of C2, or in other words, the span of the two standard basis vectors of yeah. I think I fixed the thing. You said not quite. You still get a vector in C2. So I think I fixed that, right? These are vectors in C2. At least if I didn't say that, I'm thinking that. These are vectors in C2, and then this the standard basis vectors 1, 0, and 0, 1. And then since this is a vector space over the complex numbers, then you can multiply by any complex scalar to get anything, right? It's still wrong. Everything written here is in Z. The coordinates of these vectors, I'm thinking Z1. Oh shit. Okay. Yeah, I'm thinking that Z1 is... Oh, wait. This is what I'm thinking. Okay. But I see. They can't add together because, yeah, then this is in damn it. Okay, how do I don't feel like I've worked with pairs of complex numbers as much. But I am trying to think of the fact that like Z1 and Z2. Yeah, you're right. Yeah, this is all broken. This is broken. Okay. I see that this is broken. How do I... Yeah, this is broken. Yeah, I'm thinking that this is... How the fuck? I'm trying to say that, like, I think that they should be two separate columns. But then we get back to... Like, if these are two separate columns, then I suppose that we end up with a tuple of two... Like, I'm using an isomorphism, I think. But, yeah, I need to be able to convert from... What the hell am I doing? Okay. I mean, the way I want to write this is that this would be wait. Yeah, this is broken. This doesn't make any sense. How do I write two complex pairs that are separate? Like, yeah, because if I just have a single vector or a single complex number. Okay, wait. Is it this? A1 plus B1I, and then the other, yeah, it's a 1/2. Yeah, okay. This is it, I think. Z1, Z2, right? No, because I need to multiply. Don't I need 2 rows in the second matrix? What are Z1 and Z2 at all in the first place? I think I have a lot of issues happening here. I think that this is, let's kind of come back to something that I feel is correct. I feel more confident about some of this stuff. I feel I need to kind of pause and try this again. I think instead of trying to fix it, I think it's better to just try to start fresh on a new page, because, yeah, everything was pretty broken. Thank you. Oh yeah, Leo Lectures. What do you think about the cursed notation here? Somebody was. What do you think of omitting parentheses with one argument? Like in functional programming, we often omit parentheses if there's only one argument to a function. Yeah, everything is wrong in this stuff. I need to... A column vector with 2 entries, but that's where I was getting confused, because we're multiplying... Like I can write the column vector as like the real and imaginary components, like A1, B1, but then we're multiplying by I, so then I need to know to multiply I and like shift a coordinate from the first component to the second coordinate. Something just feels super off. I think writing it out a little more carefully from the beginning, I think I'm... GL2C, I think, is fine for this. Yeah, replace all the multiplications by multiplications of complex numbers. Yeah, why am I... Yeah, I'm confusing myself a lot here. But if I'm working with this definition, if I'm working with this definition, then I need to consider the vector space that GL2 C represents, which is the vector space is GL. Here I would use parentheses because there's multiple. This is a little cursed right now. Maybe that is cursed. Yeah. So if I'm working from that definition, then I want to show that a non-trivial subspace of C2 is all of C2. There's no proper subspaces other than the trivial subspace. So, assuming that a subspace is not trivial, then let Z be a pair of complex numbers, and really explicitly I'm going to write that out here. Phi G of Z is... Okay, wait. Phi of R is I, 0, 0, negative I. So, yeah, the problem is that this object is in GL2 of C. So the transformation that corresponds to phi G, to phi R, or something, will take the first coordinate and multiply it by I, and then multiply the second coordinate by negative I, right? Because I need, like, now I'm thinking about the transformation, right? That matrix represents. So this is negative B1 plus I A1 and negative I B2 minus IA2. I think that I'm more on the right track now. A1I. And then phi s being 0, 1, 1, 0, the transformation corresponding to phi s is going to be, we're going to swap z2 and z1, right? Then I believe that this is what I mean, this first one, it may be simpler to just keep it as IZ1 and negative IZ2. If I'm on the right track, then we want to show that the span of IZ1, negative IZ2, and Z2, Z1 equals the span of 1, 0, 0, 1. So somehow we need to solve a system of equations like that we have some that we can represent, that we can solve a system of equations of a multiple of IZ1, negative IZ2, Z2, Z1, and then now this is turning into a matrix equation that I can solve, I believe. But we have multiple unknowns, don't we? I mean, everything here is true, but I don't know if I'm going to get stuck now. Oh, no, this, okay, I think I'm on the right track here. I think that this works. These K's are not the same. I don't know, this is K11, K12, K21, and K22. right? Then this is, since E1 is 1, 0, if I can represent the basis vectors as a combination of these things, then, well, we can factor out an I. So K11 times I times Z1, Z2 plus K12 times Z2, Z1. I think the two are extremely similar in that oh wait, I lost a negative, didn't I? Negative Z2, Z1. I lost a negative. Negative Z2 plus K12 Z2 Z1, right? So we need to be able to solve the system of equations, a system of equations where 1 is equal to K11I times Z1 plus Z2. Oh wait, no, oops. K11I times Z1 plus K12 times Z2. And 0 is negative K11I Z2 plus K22. Oh wait, no, negative K21I plus K12 Z1. We're going to use, so this is from the first, solving for the first basis vector, and then the second one is essentially symmetric. So from this, I can substitute K21, K21 I Z2 equals K12 Z1. So if I add that negative K21 I Z2 to both sides, and then because Z1, Z2 is not equal to, we assume that it was not equal to 0, 0. One is non-zero. Without loss of generality, assume that Z1 is not 0. then we can divide both sides of the equation and say that K12 is equal to K21I Z2 divided by Z1. Oh wait, I got something wrong here. K21, oh, this was supposed to be a K22 Z1. This is a K22 Z2 Z1. This is a K22. Oh wait, what the hell? K21. So we assume that Z1 is non-zero, so we can solve for K22 in terms of K21 I Z2 divided by Z1. So now that we have or do we solve for or maybe better yet, we solve for one in terms of the other, where we assume that is this the right way to solve for that coefficient, or more so if we assume Z1 is not zero, maybe we solve for Z2 in terms of Z1. Oh, I feel like I'm not doing the right approach on this. Yo, dude. JC's getting there. Not all non-zero Z1, Z2 get full dimension 2 here. Yeah, but if you add in Z1, Z2 to the span, yeah, I mean, that's my thought, that, like, it's not always going to get dimension 2. Okay. So I'm peeking at the hints now. I gotta pee real quick, but I'm glad that you said that I'm cooking, because I feel like I was on the right path somewhere here, right? Like I feel like I've got something coming. Something is working here, sort of. Like I've at least fixed the type errors everywhere, right? Like I think I've fixed all the type errors. And yeah, for sure, I was thinking that not all non-zero Z1, Z2 get full dimension 2. Like, clearly. Oh, wait. You are a chicken ready to lay this egg, and this egg is ready to hatch into a beautiful solution to this exercise. That's hilarious. Okay. I gotta pee, though, unfortunately. That's partly why I paused. So I'm going to be right back. I feel like we're somewhere kind of... We're getting closer now. Like, I know I need to use the fact somewhere that the only assumption I can make at the moment is that z is not 0. So somewhere I need to use the fact that one of the two components is non-zero. And then that hints to me that I want to divide by that number somewhere. So but I could also try to use the fact that I can multiply everything by 1 instead of solving this equation. I can multiply the second line. If this is the first fact I know, and then this is the second fact I know, then yeah, I can multiply the second equation by the first, and then I still have a solution of like 0 equals like some relation of z1 and z2. Oh, I gotta pee in a second, but like that's another bit of information that I could use. Dude, that would be awesome if you wanted to help me like get a solution. I mean, I could just ask ChatGPT, but it's so much more fun to get help from somebody like you, you know? I feel like I'm on the right direction. JC struggling with this question while I am struggling with formalization. Yeah, timestamp it, and I'll just avoid spoiling it. I gotta go soon, though. We've already done 3 hours. Holy fucking crap. Like, I ranted a lot about other stuff. I ranted a whole lot about other things today. About coding and productivity apps like bullet journaling. I ranted a whole lot, and we reviewed section 1. We reviewed the stuff that we worked last time. Now, one thing is that I wanted to see if I could tackle this exercise from the definitions, just from like the raw definitions. And it gets pretty in the weeds and like pretty little gnarly, you know. I feel I'm on the right path here. So this entire approach here is just using our second line, right? Our second equation. But then I could also get some more information by multiplying both equations together. That's another bit of information that I have. 1 times 0 is 0, and the right-hand side I can do k11z1 plus k12z2 times k21z1 plus k22z2. It's just super freaking messy right now, but I mean, especially because now we're going to get squared terms and stuff. I don't know if this is going to help any. But that is, I mean, that's the thing that we could try. I don't see it immediately being a whole lot better. I'll see if I can try to recover or finish this approach. But then the other approach that I'm considering, from last time, I said that there was a proposition that we can use as a tool, and that I think that I wanted to like actually really review more deeply all of this other stuff, but then I got just super sidetracked and interested in trying to prove this just from definitions. But I think that we can use property 3119. This fact sounded very relevant, and it has to do with eigenvalues and eigenvectors. So prop 3119, let me just rewrite this. Let's see if we can use what is this tool? You can get there with what you're doing. If I were to give a hint, it's put IDZ in there into the span. IDZ, so you mean... Why do we... Oh, wait. Oh, because we know... Okay, yeah, because we know that I'm getting kind of lost in all the because we know that it's not the zero transformation that maps everything to zero, then there also must be the identity transformation, right? Is that what we're saying? Like, because t is not zero, or because... What is this? Because w is not zero, then... I mean, I believe this. I'm just, like, confused about this whole mapping between, like, GL2 of the complex numbers. Is this some sort of, like, currying thing? Is GL2 of C the same as GL of C? No, I don't think so. Like, if it were, then our vector space could be GLC. Is it? Is this some sort of currying thing? I know that these two are isomorphic. But is the second one also isomorphic? Because ID of... What I'm trying to get at is something like this. Like... But well, uh, I'm like still, I'm still okay. Yeah, let me read. Oh, fee of ID. Okay, yeah. Okay, so fee of the group element ID or of E. Uh-huh. Which should be 1001, and this should, as I expect, be, I mean, as I'd expect, like, this is what I'm trying to get to. Like, I'm trying to say that we must have a transformation, like, an identity. We must still have some identity transformation of some kind, and it's by using the group element E. Okay. Huh. Okay. Let's see. I think that's a pretty solid hint right there. I think that's a really super solid hint. Take two, take three, something or other. Yeah, there's something missing because I was finding the span of. I was trying to say the span of phi r. Well, Yeah, I see. Okay, the span of phi g z for all group elements G in D8 I think is the same as the span of that? I think I was missing maybe the identity. But maybe not. Like, dude, do I need to do R to the K and S to the K on this? Like, I feel like I was something feels off. Like in my assumption at the beginning that I can reduce to just phi R and phi S, and using some sort of like homomorphism property that phi R to the K Z is equal to phi R of Z to the K or something. Because or phi to the K, like applying phi K times this part is true. Because the span representate. So if you rotate the square 90 degrees, like the span is the set of all linear combinations of these, but if you get a linear combination, yeah, I think I made something. I think I did something wrong at the beginning, saying that I can just work with phi R and phi S. I think I need to work with phi. I think that this step at the beginning was wrong, and that I should be working with the span of phi R to the K Z and phi S Z S R to the K Z, because now this includes phi E when K is 0. So I was missing the identity image or the identity action or something. So now this is the span of and now this is equal to a times I to the k 0, 0, negative I to the k plus b times 0, negative I to the k, I to the k, 0, all multiplied by z. Like, I can factor out the z from these linear combinations. So where do I go from here? Oh, I lost my z somewhere. Since we factored out a scalar, then the span of that is the same as the span of some other. I mean, it would be A prime and B prime, but I think that this is a lot closer to I'm not quite sure if JC is cooking, but this can get him there. I think I'm close. I think that this approach is gonna get there. Right? I'm not sure if I'm cooking either, but I think that we're getting very close here to something. Yeah, I'm not sure if I'm cooking either too, but we want to show that we can find coordinate vectors that represent 1, 0, yeah, we want to express 1, 0. This is like our goal from definitions. I think we're almost there. Maybe Locke and JC's progress are linked. Yeah, we're like linked across distance. I gotta go. Dude, I have work this afternoon, and I need to actually get some guitar practice in. Otherwise, my guitar community is going to get mad at me. I totally skipped last time. I wanted to at least... Dude, I think that's almost there. I just need to be off camera, I think, to stare at it for a second longer. But I think that that's almost... I think that we almost got it. Now, I wanted to see if we used some heavier machinery. Let's just write down this proposition. And I hope that tomorrow I can get a practice rep and finalize this proof, maybe both ways. But I think that this is pretty useful tool. If G to GLV, if we have a representation is a rep of degree 2, i.e. the dimension of V is 2, then phi is irreducible if and only if there is no common eigenvector V to all phi G with G in the group. This looked like it would be a fairly direct proof if we use this proposition, right? Like this looks very, very similar to our situation. The dimension of V in our case is C squared is degree 2, clearly. Phi is irreducible if and only if there is no common eigenvector to all phi G. So we can take a look at, we can find the eigenvectors of what are these again? I'm blinking. Oh, I to the k, negative I to the k, 0, 0. So, I'm going to denote this matrix R and this matrix S and well, I guess it should be RK or something, and SRK is 0 I to the k negative I to the k. So if there is no common eigenvector v to all Fiji, so how can I find... I feel like we would want to split to somehow, if we could use that theorem, we'd use I, R, and S. And I believe I can find eigenvectors of these very clearly and see that there's no eigenvector in common to these, and then claim that RK is R to the K, which I think is clearly true. Yeah, or show that RK is R to the K, and then SK is S applied to RK or something. Damn, I'll probably stream in 30 to 45, but you're getting there with this one. Don't spoil yourself with my stream, though. There is no machinery but beyond basic linear algebra that should help much here. Yeah, I do want to prove this property. Which is why I wanted to see if I can... This is why I wanted to see if I could try to do it from without this property, and then that would help illuminate and guide me toward understanding why this property is true in general. Like, try to understand it once without, and then try to prove it with this. This proof is not constructive? Or... Oh, the not Q, the contrapositive is not constructive? I didn't know that. Oh, I think I heard that somewhere. Somewhere I did, somebody's YouTube video, I did find that out. Yeah, that's interesting. Ooh. You basically prove this property as part of it. Nice. Yeah, well, you know. You're watching me live. You're watching me struggle live. So, you know, we'll get there. We'll get there. With a few reps of rep theory, with a few more reps, we'll get there to where I can share this this proof with you all. Thank you for hanging out with me. I'm gonna take a quick break. I'm gonna set up the guitar stream, and then I'm gonna raid the guitar stream and start practicing some classical guitar. Thanks for hanging out with me, everyone. This has gone on long enough. I made some... I feel like I made some decent partial progress, and I showed a lot of dead ends and getting stuck, and, you know, how I was thinking along with the... You know, with this problem, and, like, I showcased some dead ends. Yeah, I'll try to prove it with the property first. That's why I think I have a sketch here that I can I believe that if I can just show that there are no common eigenvectors of these three matrices, then I think that there's some details to fill in next, but after that, then I can claim that there's no common eigenvectors for the powers or the combinations of those matrices, I guess. Well, and then if there's no common eigenvectors to those, then I know that there's no common eigenvectors to all. There's no... Okay, yeah, there's... So if... Okay. If there is a common eigenvector... Or if there is an eigenvector, it can't be common to all of them. Is a way to say this, right? I mean, this is an if and only if statement, so I need to also prove both directions. Oh, wait, no. This is a proposition, so if I assume that this proposition is true, then I just need to show that there's no common eigenvector to all representations. I'm still figuring out the language of all this stuff. I'm feeling quite rusty. But hey, I showcased some problem solving this time. Last time that we did representation theory in this chapter, it was 100% note taking, and I was hoping to do note taking today. I was planning on taking notes, but this stream actually ended up being almost entirely from my brain. Like, there was very little note-taking. This time around, it ended up being almost all problem-solving. So I'm at least, if nothing else, I leveled up a little bit today, just getting more active for the first time in this section. Last time I was just kind of taking notes and copying stuff. I reviewed my notes enough to be like, okay, yeah, I think I remember all these definitions and some of these things, but I was just reviewing notes, and then I was trying to apply that theory and try to tackle the problem for the first time. So concretely, there's something that's actually a step forward in today's stream versus a month ago when we first looked at all this stuff. So, yeah, don't worry. Once Locke figures out his problem, I'll magically figure out mine. We'll see if I can give it a shot privately. I don't know. Maybe I should do a video of things I really struggled with at first, because definitely a bunch of stuff. But it's so different. I mean, yeah, like if you could relay the fact that you were stuck on something, I think a lot of people would appreciate seeing that. But what I'm aiming for, I don't think anybody's done. Like, somebody being stuck truly in real time. Like, you're watching me try to solve math problems in real time, not like recounting a story and telling a story about being stuck, but you watched me actually be stuck. So it's different. And yeah, we all forget, like, once we learn a thing, we forget how hard it was the first time around. And if nothing else, like, I want to like try to normalize the idea that we all get stuck. Like, to, you know, potential high school students or tutoring students, I want the students that I'm tutoring to see that, you know, I'm getting stuck. I don't know. I'm lost. I went down some dead ends. I made some legit mistakes today, and then fix those mistakes. And, you know, in a few days, I'll come back to this and be like, oh yeah, no problem. And I can repeat the proof. But there was a time when I got stuck on this thing. And it's just the same way in high school math. Yeah, I definitely still get quite stuck, but usually it's a research thing that you can't show. Is it that you can't show because you don't want to give away the secrets? Like, because yeah, research, you all need to actually care about secrecy, about, you know, the secret things that you're working on. Or is it that you can't show because it's too in the weeds, too complex for us to understand? Like for the audience, is it that you don't want to give away the secrets, or that the audience won't understand what you're talking about? Both? Indeed. Yes. The answer is yes. Well, that's cool. Tips are always welcome. Feedback is always a gift. If you all ever think that I'm working inefficiently, like if you have tips of how I could, I don't know, study better, that is actually I'm more interested in that than getting better at math. Like I'm actually more interested in talking about how to study math than the math itself, if that makes sense. So, thanks everyone. If anybody else would have paused earlier or started over earlier, or don't give up on this first attempt, which was getting pretty gnarly. I don't know. I feel like I stopped at the right point in some of these things. Like I got stuck here. I just realized that oh shit, I have total type errors. I looked at the chat right about when I was I think I'm super wrong. Going in the wrong direction, and instead of trying to recover and try to fix the errors, sometimes it's okay, let's go back to something that I know is totally true. Everything after this I feel a little less confident in. I feel totally correct that this first part is correct. Let's start a new sheet of paper, and on that new sheet of paper, let's start over fresh and try to forget the dead end path a moment ago. Yeah, a priori, it's quite hard to know when to move on and when not to, because essentially knowing that is intuition. Yeah. And I feel I have some intuition, but it takes time to develop intuition. And yeah, intuition it's a hard thing to develop. Okay, I gotta go. I really gotta go. Thanks for watching, everyone. Bye. Yeah, I'm going to set up the guitar stream. And then after this song, I think that we'll set up a raid. All right, bye.